Hi there, I'm Finbar Argus and I'm here at the Aeromechanics branch of the NASA Ames Research Centre. This is where they do a lot of research for rotorcraft, so your helicopters and your tilt rotors, like you can see here. My project here is I'm working on understanding the critical flow over aerofoils and over rotor blades. So what critical flow is, it is the region of flow in between where it's slow enough and at a small enough size scale that the flow is completely laminar over your blade. By laminar, I mean it is smooth over your blade. So your airflow is nice and smooth over the whole blade. The supercritical region is where your flow is turbulent over the blade, and so that means that the flow is rough and it is rolling over itself and staying connected to the blade. So the critical region is in between these two regions. And at this region, when going down from a subcritical region to this critical region, you can lose a lot of drift and create a lot of drag on your blade, which is typically unwanted. So what I want to do is I want to understand in what different flight conditions and what different wind conditions this could be dangerous, or what will happen in these conditions. The applications for my project are for micro air vehicles, or really small drones. And I want to understand how the flight of these drones could go into the critical regime and understand what happens when it is in that regime. So for example, there could be a certain maneuver in a certain wind condition that causes one blade to go into this critical regime, and it could cause a crash. So by improving the understanding of this, we can then avoid these crashes. Another extremely exciting future application is the Mars helicopter, which also operates in a critical regime because of the extremely low density on Mars. I am super excited to be here, and I can't wait to spend the whole 16 weeks here and learn off the smartest people around, and I'm just gonna love it all.